reads any of the stuff I've written or anybody is interested in my work. But it's especially neat when it's people back home. So I grew up in the Fox Valley, but in the town of Ottawa. So some of you surely know Ottawa, and Ottawa's right on Interstate 80 in LaSalle County, kind of around LaSalle, Peru, and Streeter and Morris, and some of those other towns out there, out in the flatlands, which is an interesting place to grow up when you become obsessed with dinosaurs at a not too young of age. I got into it when I was a teenager, but no dinosaurs in Fox Valley, no dinosaurs in northern Illinois. Actually, nobody's ever found a dinosaur in Illinois, and that is, I have to admit, one of my kind of bucket list dreams someday to be the first person to find a dinosaur in my home state. It's not a very likely thing, let's say, because in order to find dinosaur bones, you have to find them inside of rocks. Any fossil is, a fossil is just a sign of any ancient life, whether it's a bone or a tooth or a skeleton, if we're lucky, or a leaf or a footprint or whatever the case may be, some record of something that used to be alive. And that's what I spend, my career going out and looking for and studying. And we have to look inside of rocks to find fossils, because a dinosaur skeleton really is the bones of a dinosaur that lived many, many tens of millions of years ago, that's been buried in sand or mud and then turned into rock. And so to find a dinosaur, you need to go to places where you can look at rocks. And you have to look at the right type of rock. So you need to go to places where there were rocks that were formed during the time that dinosaurs lived. So in the Triassic period, the Jurassic period, or the Cretaceous period, which are the time intervals that dinosaurs lived. And you also need rocks that were formed in the types of environments that dinosaurs lived in. So you need rocks like sandstones that were made from the sand on beaches that dinosaurs may have lived on, mudstones that were made from the mud that flooded from rivers or from lakes, those kind of rocks. And this is just a roundabout way of saying that those kind of rocks, we don't really have many of them in Illinois. There's just a few rocks at the very southern tip of the state, and I mean the real southern tip of Illinois, that were made in the Cretaceous period, back when there was a seaway that covered southern Illinois. And it wasn't just any seaway, by the way, it was the Gulf of Mexico. It reached all the way up to Illinois back then. And the Gulf of Mexico, there were beaches on the Gulf of Mexico in Illinois about 60 something million years ago. And there are fossils in those rocks that were formed on those beaches, but so far people have only found leaves and shells and those sort of things. So it's my dream one day to be able to go down there and find a dinosaur bone in those rocks, but they're very challenging to work in because all those rocks are in the middle of a forest, a national forest actually. And so as paleontologists, that's not a place where we like to look. Because when we go out and look for fossils, I spend most of my time in places like New Mexico or Wyoming or Colorado or Montana, places out west where there are vast landscapes, where there are deserts, where there are badlands, where there are lots of rocks being eroded on the surface. There's not a lot of buildings, there's not a lot of roads, there's not a lot of forests covering up the rocks. Those are the sweet spots for finding dinosaurs. And some rocks in the middle of a bit of forest at the southern tip of Illinois, not so ideal, but still I hold out hope. And maybe some of you younger folks here that live in Illinois, actually maybe this can be your dream too, to go out and find those dinosaurs, because I don't live in Illinois anymore. I live all the way across the ocean in Scotland, and I'm joining you now from the capital city of Scotland called Edinburgh, and this is where my career ended up taking me. I never would have dreamt that when I was growing up in Ottawa and I was going to Wallace Grade School and Ottawa Township High School, and even when I went off to college and then I moved to Chicago to go to college, I never thought I would live so far away from home. But being a scientist, science is a global thing. There are fossils all over the world, and there are great universities all over the world, and I'm very lucky that I got an opportunity to get a job teaching here in Scotland at the University of Edinburgh, which, for those of you back home, you probably won't believe this, but I swear it's true, but the University of Edinburgh was founded in the 1580s. So this university I teach at is about 200 years older than the United States as a country. And the University of Edinburgh, it's a wonderful university, has a long history. The entire science of geology, the study of the earth, was essentially founded in Edinburgh by a graduate of our university named James Hutton. And there have been many other great paleontologists and geologists and biologists over the years. Even Charles Darwin himself, who came up with the theory of evolution by natural selection, he came to Edinburgh to study medicine. So when I got this opportunity to move over here, I took it, and that's why I'm living so far away from home. Now, another big part of that, though, is that my wife is from England, so we were looking for jobs on both sides of the Atlantic, and we found ourselves here, and we love living here. We have a little boy now, which is one of the reasons why I'm doing the talk at this time, because this is the time where we've got past his dinner routine and going off to sleep, so I have some free moments. Anyway, that's just a little brief kind of background of, again, a roundabout way of saying I'm from Northern Illinois. I went into the career of digging up dinosaurs. It's taken me all over the world, and it's landed me here in Scotland, where I'm teaching at a wonderful university. I'm one of those lucky people in a lot of ways, really, but particularly in being able to make a living out of digging up dinosaur bones and studying dinosaurs and describing dinosaurs and naming dinosaurs and writing about dinosaurs. It's the most amazing thing. I mean, it's just, you know, whenever I stop to think about it, I just realize how fortunate I am to be able to do this job. It's an unusual job, and it's a job that I love. And it's a job that has taken me all over the world. And I've worked with amazing people all over the world digging up dinosaurs and other fossils too, because it's not only about dinosaurs. And for some of you young ones out there, it's okay if you like animals other than dinosaurs. So I also study mammals. I study crocodiles. I study pterodactyls. I study all kinds of things. And in fact, when I started out as a student in Illinois, I collected fossils around Ottawa and around other places in the Illinois Valley and the Fox Valley. There's no dinosaur fossils, but there are actually lots of fossils in Northern Illinois of things that are even older than the dinosaurs. So the dinosaurs lived from about 230 until about 66 million years ago. And actually, they still live today as birds, which is something we can talk about because birds evolved from dinosaurs. But the T-Rexes, the Stegosauruses, the Brontosauruses, the Triceratopses, all of those famous dinosaurs, the ones that you see in Jurassic Park and you see in museums, those things, they died out 66 million years ago. They got their start much earlier, 230 million years ago. But some of these fossils in Northern Illinois, which you can go out and find, are fossils of things like clams and corals and other creatures with shells that lived in the ocean. There's fossils of jellyfish. There's fossils of plants, of leaves, of ferns, of stems, of parts of trees. Incredible fossils from Northern Illinois. And these fossils are more than 290 million years old. These fossils were being formed at least 60 million years before a dinosaur ever lived. And that's really cool. And so although I became obsessed with dinosaurs when I was in high school, I knew that I didn't live in the kind of place where you could dig up dinosaurs. So instead, I also became very interested in the kind of fossils that were around me. And so when I got my driver's license, my parents were very nice, and they occasionally let me take the family car out to go look for fossils. And I collected fossils. I had a great teacher in high school in Ottawa. Joe Jacobchek is his name, and he's retired now after a long career as just the most inspirational teacher you could imagine. And what he does now is he's a guide at Starved Rock, for those of you that know Starved Rock State Park. So if you go out to Starved Rock, you do one of those tours, and you see a guy who calls himself Joe, Mr. Jacobchek. I don't know what he would call himself out there, but you can recognize him instantly because he just has an infectious enthusiasm for the park and for nature and prehistory in Northern Illinois. He was my teacher. And he took me to places to look for fossils. He introduced me to the little slivers of rock that are exposed along some roads, along some stream banks, deep in the forest. And that's how I learned to collect fossils of these things that were older than dinosaurs. And then when I went off to college, what I really wanted to do was study dinosaurs. And so I was very fortunate to be able to move to the big city, to move to Chicago, which, you know, for somebody growing up in Ottawa, this was like the most amazing thing at 18 years old, to go and live in the big city. To study dinosaurs in part, but also because every Monday and Tuesday were White Sox half price nights back then, at least. And when the Sox won the World Series was when I was in college. So the whole thing was wonderful, living in Chicago and going to school there. But I got to work with a professor, a guy named Paul Serino, who is from your area. He grew up in Naperville and in Aurora, in that part of the suburbs. And Paul actually comes from a family of there's 6 siblings, and they're all PhDs. They're the most crazy overachieving family. And some of them are professors, and some of them gone into other lines of work. And actually his sister, Paul's sister, is a professor in the big town, the other big city in Scotland called Glasgow. But anyway, Paul is a guy like me who grew up in Northern Illinois. And so he became my hero, really, when I was in high school. And I really wanted to study with him because he went from Northern Illinois and he went into a career in paleontology, and he traveled the world and he dug up dinosaurs, and he found these amazing dinosaurs, mostly in Africa. So much of what we know of African dinosaurs is because of Paul and the work that he's done in collaboration with his fellow scientists in Morocco and in Niger in particular. But he's also worked in China. He's collaborated with Chinese scientists. And he's really worked all over the world. And when I was in high school in the late 90s and early 2000s, Paul was in the news all the time. He was always unveiling some giant new dinosaur from Africa or from China. And so I followed that news, religiously. And anytime Paul was doing some kind of public talk, and he would do talks at libraries, and, in a non-pandemic world, I would be there in person with you guys now, by the way, because I always come back home, at least until this year in July. But Paul did talks at libraries. Paul did talks at museums. Paul had his own exhibits he would put up, like in the Chicago Botanical Gardens and places like that. And I would go to as many of those things as I could. I became a little bit of a Paul Serino fanboy or groupie. And so after a while, we started exchanging emails. I was really a very brazen teenager in some ways. I was very, shy and stuff when it came to actually being in high school. Being in the building of high school and kind of dealing with other high school kids and, peer pressure and cliques and, talking to girls and all that stuff. I was so shy. But when it came to emailing and sometimes even phone calling famous paleontologists, I had no problem doing that. So I actually got to know Paul a little bit when I was, a junior and senior in college and in high school. And he encouraged me to apply to the University of Chicago, and I did. And I went there. And very quickly, I started working in his lab, and this thing was like, Willy Wonka's workshop for me, the chocolate factory. This was incredible. This giant lab full of dinosaur bones that Paul had brought back all over the world. And he taught me how to identify bones and catalog bones and recognize different types of dinosaurs. And the summer after my sophomore year of college, he asked me if I could stay during the summer, and he showed me a drawer of fossils, and he said, these are some dinosaur bones that I found in Niger in Africa, and I think they might be a new species, but I'm not sure, and I'd like you to figure it out this summer. And this was, this was indescribable, just being asked by my hero to work on these dinosaurs with. And so I stayed during the summer. I worked on those bones. There was part of the skull there. There was part of the jawbone. There was part of the bones that surround the brain. There were some parts of the backbone. There were lots of teeth and so on. It was just a fraction of a skeleton, but it was enough to realize that, first of all, yes, it was a dinosaur. Second of all, it was a meat-eating dinosaur. So it's what we call a theropod dinosaur. That's the T-Rex group, the Velociraptor group. And we could tell it was a very, very, very big theropod dinosaur. We could tell just from those bones that its head, its entire head, must have been about 5 or 6 feet long. So, about as long as an average person, really. And there's another type of dinosaur from northern Africa called Carcharodontosaurus that is a giant predator. And Paul had actually found its skull in Morocco. And so we determined that these bones were very similar to the Morocco Carcharodontosaurus, but these were from Niger, they were from another country, they were from another time interval, another rock type. And so we realized we had a second species of giant meat eater from Africa. We gave it a name, Carcharodontosaurus agudensis, we called it, and we published a scientific paper on it, and I got to name this dinosaur and write about it. And, you know, it was my first real taste of being a scientist, and it became just enthralling to be able to do that work, to be this kind of, you know, deep time detective where we have these little clues, these bones, these teeth, only parts of a skeleton, just from little, you know, different pockets of the world, and using that evidence to figure out what these animals were and when they lived and what the earth was like tens or hundreds of millions of years ago when they were around. Just amazing, just remarkable. And so, you know, I fell in love with it. I knew absolutely that, I mean, I already was in college. I was already studying geology. I already wanted to be a paleontologist. But by the time I got the opportunity to really start doing science, to start doing research, to working on these new fossils, I completely fell in love with it. And so I continued working with Paul. We worked on some other projects. And then from there, Paul took me on my first proper dinosaur digs. And the first digs we went on were out west. They were in South Dakota and Wyoming, where Paul was digging up the bones of one of these giant long-necked sauropod dinosaurs, a brontosaurus type of dinosaur, in Wyoming. And then in South Dakota, he was digging up the bones of a duck-billed dinosaur called Edmontosaurus, one of these big plant eaters with a beak, kind of like a duck, that lived at the same time as T-Rex. So I got experience going out there. And then when I was a senior, Paul asked me to come along on an international trip to go to Tibet with him. And I couldn't believe it. This was my first time I'd be able to go abroad and do some science. And we didn't really find much on that trip. There were lots of reasons we didn't. A lot of those were political. Those of you, you know, of the younger crowd here don't even want to get started about Chinese politics and about the history of Tibet. But let's just say incredibly complicated. Ask your parents. It was hard work. You know, we had all the permits, we had all the permission, but basically every town we went to, our passports were taken, we had to give money, we had to wait, and it wasn't the best way to dig up dinosaurs. So we didn't find much, but I did get introduced on that trip to a lot of wonderful Chinese scientists, including really the grand you know, old man, if I could call him that, of Chinese paleontology, a guy named Zhao Zijin. He was in his 70s at that time. He was starting to be in failing health, unfortunately, but he came with us to Tibet, up to elevations of like 15 or 16,000 feet in the Himalayas. He had an oxygen tank. In hindsight, it was really stupid for him to have done that. But he really wanted to come along because in the 1970s, he was sent to Tibet during the Cultural Revolution, again, for the younger crowd here, ask your parents, and he found fossils out there. And so he wanted to go out with us and see if he could find those sites again. And so while we didn't find a lot of dinosaurs, I got to know him on that trip. I got to know some of the younger Chinese scientists as well. And I fell in love with China, and I fell in love with traveling. And so later, after I finished college, I went to do a master's degree, and I went to England to do this, to a place called Bristol, which is a city that's a couple hours west of London. And I was really lucky to get a scholarship to go out there for a couple years, this thing called the Marshall Scholarship, which the British government pays for. They pay for about 40 American students every year to go and study in the UK. And this is part of the gratitude for the Marshall Plan, which basically rebuilt much of Europe after World War II. And so I was the beneficiary of this scholarship, which had to do with World War II. I mean, amazing. Like, who could fathom that, like, some guy from, you know, the cornfields would, you know, whatever, 60 years after the war would get to benefit from this? Crazy. But so I got the scholarship. I applied on a whim. I got it. I went to Bristol for 2 years. That's where I met my wife when I was a student there. So I had no clue that anything like that would ever happen. There we were. And I also got to work with new people, with new scientists, that because England's a smaller country, because there's not as much rock to dig up dinosaur bones. A lot of the paleontologists in England, although they do collect fossils, they tend to do more theoretical work or more statistical, kind of mathematical work, studying evolution, studying trends, patterns of how species diversify over time, how species change with climate and with environment. So I got to work with some leading scientists. A guy named Mike Benton in particular is a very famous paleontologist who's written a lot of the textbooks. And I learned new things, and I met new people, and I got to travel around Europe, and I got to visit museums in Germany and in Poland, and eventually in Portugal and in Lithuania, and just, in France, and so many places, because it's so easy to hop around Europe. And so that opened up, new worlds to me. And then I came back to the US then to do my PhD degree. And I moved to New York City. So I thought Chicago was the big city. Chicago is a great, wonderful, amazing city. But New York is a whole nother beast, both good and bad. And so I lived in New York for about 5 years. And I did my PhD at Columbia University. And they have a program with the American Museum of Natural History, the world's greatest natural history museum, the world's biggest and best collection of dinosaur bones, which including the very first fossils of T-Rex that were ever found, including a lot of the most famous dinosaurs, the ones you've heard of, Triceratops, Stegosaurus, Brontosaurus, and so on. And so I was very fortunate there to work with another mentor, a guy named Mark Norell, who is an eminent paleontologist, one of the world's great dinosaur experts and dinosaur hunters, and a guy who's also worked all over the world for 25 years, actually for 30 years basically now. He's gone to Mongolia every summer to work with Mongolian colleagues to dig up dinosaur bones. So as a PhD student, I got to describe these dinosaurs from Mongolia, including a new tyrannosaur species called Aleiuramus. And we also worked together, Mark and I, in going to different places, doing field work, and we started a great program with colleagues and friends in Romania that we continue to work on. Very sadly, our dear friend Macias Bremer in Romania passed away yesterday, 49 years old, which was a terrible shock and a terrible tragedy. But being able to work with him for almost a decade, this is the best fossil hunter I ever knew. This is a guy who was an oil geologist who looked for fossils with his 2 young boys in his spare time. And I got to meet him and work with him through Mark. So I think you're starting to see, I've had all these opportunities to work with really incredible people all over the world and to study with great mentors and to work with colleagues in different countries and to become part of teams and to dig up dinosaurs, but also to study dinosaurs in museums and do more theoretical work on evolution. And that's what really brought me to today, to then going to Edinburgh and getting on the faculty here and starting up my own research group and my own lab and having my own students. And I have a lot of them now. I probably have far too many students, but I love taking new students. I have 6 PhD students right now. 6 people are studying for their PhDs with me, and they come from all over the world. It's incredible. If I can count off the top of my head, I have a PhD student from Austria. I have a PhD student from Poland. I have a PhD student from the US. I have a PhD student from Italy. I have a PhD student from Greece. And I have a PhD student from Chile. And then I have master's students. We run a master's course, a 1-year master's course here. And every year I have, somewhere between, 3 and 5 students in that course. And they come from all over the world, which is great. And they work on lots of things. And so what's really neat now is that we're not only working on dinosaurs here. We are working on dinosaurs, by the way, and we do field work, and there are dinosaurs in Scotland. There's one place here in this country that's a beautiful island off the west coast called the Isle of Skye. And it is one of the most gorgeous places in the world. And that's why a lot of big Hollywood blockbusters film out there. So Transformers and Prometheus and these other movies have filmed on Skye, because of these dramatic backgrounds of craggy mountains and misty moors and sea coasts and beautiful forests and peat bogs and all just remarkable environments. Because filming is so popular on Sky, now it's overrun with tourists, so it's a bit harder to go there and actually get accommodation and have space to go and dig up our dinosaurs. But we do work there, and we worked there for a while. We worked with a local guy on Sky, a guy named Doogie Ross, who is one of the most incredible people I've ever met. He grew up on the island. He speaks Gaelic as his first language. That's the native language of the Scottish Highlands and Islands. You might think that everybody in the UK, the United Kingdom, always speak English. Well, of course, English is the main language here, but there are people like Doogie who grow up speaking other languages as their first language. He's never really left the island. He left school when he was young. He became a builder. He's a very good builder. And so he builds houses. He has a small flock of sheep. He has some other farming interests. And meanwhile, he collects fossils and he collects artifacts. And he built his own museum out of the ruins of a one-room schoolhouse from the 19th century. And if you ever go to the Isle of Skye, you can go visit this museum. And it's an otherworldly experience to go into this reconstructed Highlands one-room schoolhouse where there are dinosaur bones and other fossils splayed out, the things that Doogie has collected over the years. And so we work together. Pretty much every year we go to Skye, and we found a lot of new dinosaurs and other things too. A lot of what we find are not bones, but are footprints. So it's the footprints that the dinosaurs left behind about 170 million years ago in the Jurassic period, when Scotland was very different from today. If any of you know about Scotland, this is not a tropical paradise, let's say, but back in the Jurassic, it was like Florida or like parts of Spain. It was this lush subtropical world teeming with dinosaurs, leaving their footprints everywhere. We have footprints of giant long-necked sauropod dinosaurs. We have footprints of meat-eating theropod dinosaurs. We have that were about the size of jeeps, more or less. We have footprints of stegosaurs, the dinosaurs with the plates on their backs. We have footprints of duck-billed dinosaurs, all kinds of things. And we have some bones of these animals. But the best bones we have are actually pterodactyls. We found bones of the pterodactyls that flew above the heads of these dinosaurs, including a beautiful skeleton, the head, the neck, a lot of the wings, a lot of the body, that one of our PhD students found. And Amelia Penny is her name. Like most of our students, she's a young female. The vast majority of our students are young women now. The field has really changed from what it used to be, a bunch of cowboy type guys going out digging up dinosaurs. That's ancient history. And so Amelia found this fossil, the most amazing fossil that's ever been found on Skye. And it's now sitting in my lab. I haven't been into the lab since March because of the shutdown. We're still under a pretty strict lockdown here. But it's there, and I have another student who's working on it. So Amelia actually studies the origin of animals and the origin of skeletons. So she found this pterosaur. She doesn't even work on dinosaurs or pterodactyls, which is incredible. So we made it a project for a new PhD student named Natalia, whose family originally is from Poland and then moved to England. And she studied in Manchester, one of the main cities in England, and then came up to Scotland with us. And so she's doing her PhD studying this pterodactyl. So we have dinosaurs, we have pterodactyls, we dig them up on Skye, and then a lot of the other work we do in my lab, though, is not about dinosaurs. It's about the early evolution of mammals, about our early history, about how our ancestors survived the extinction that killed off the dinosaurs, except for birds, and started to prosper and led to what we are today. And we also study crocodiles. And we use CAT scanners quite a bit. We have a CAT scanner in our department where we can put in the skulls of these fossil crocodiles and use the x-rays of the CAT scanners to see what the brain cavity looked like, what the ear cavity looked like. We can use software to build digital three-dimensional reconstructions of the brain and of the ear and of the sinuses and of the blood vessels and of the nerves. And this tells us a lot about how smart these animals were and how good they could smell and how good they can hear. And so we're doing a lot of that work, mostly on crocodiles. right now, but also on mammals and also on dinosaurs. And so basically now I have students that are studying all kinds of things. And it's really fun to work with good young students. Let me tell you that. It's the best part of the job because I learn new stuff all the time. I mean, I trained studying dinosaurs. That's what I knew, learning from Paul Sereno and Mark Norell and studying all these dinosaur bones when I was a student. But now I'm learning all about mammals and all about crocodiles and all about pterodactyls from working with my students, which is so much fun. And the other thing that I do, and this will be just the last little bit, but the other thing, of course, is that, I love to talk about dinosaurs and evangelize about dinosaurs and write about dinosaurs. And I take pretty much every opportunity I can to tell people beyond the university why dinosaurs are important, why they're interesting, why they're relevant, why studying fossils from the distant past is important to us today, why studying fossils can tell us about how real species, real plants and animals have responded to real moments of climate change, of environmental change. What happens when big volcanoes erupt? What happens if sea level rises? What happens if an asteroid hit? Life has been through this before. That's why we study fossils. And I love to try to reach people and tell them that story. So I do a lot of writing. I've written some books for kids. I've written a textbook. And then a few years ago, I wrote The Rise and Fall of the Dinosaurs, which was a lot of fun to write. It was the first time I tried to write in kind of a popular science book for adults. And what I tried to do in the book was tell the story of dinosaur evolution, of where dinosaurs came from, of how they started small, they started humble, how for tens of millions of years they were really being outcompeted by their crocodile cousins. And then the crocodiles mostly went extinct, not all of them, of course some survive today, but most of them went extinct. Dinosaurs were able to survive this big extinction, which was caused by global warming, by the way, caused by volcanoes back then. And then afterwards, dinosaurs spread around the world and they got bigger, and some of them grew to enormous sizes, bigger than Boeing 737 airplanes. You can believe that is true. And how they evolved horns and spikes and frills and duckbills and so on. And how some of them became T-Rexes and the top predators that ever lived, but how some of them got smaller and developed feathers and turned those feathers into wings and started to fly and became the birds of today, the only dinosaurs that survived when that giant asteroid came down and killed off the T-Rexes and the long-necked dinosaurs and the Triceratopses and so on. So that's the story I try to tell in the book. It's kind of a biography of dinosaurs, if you will, but I try to weave in there some of my own stories of studying dinosaurs and a lot of stories of my colleagues and my mentors and the people that came before me and the people that I work with and the people that inspire me, both because they deserve a lot of credit and they're interesting people and people like reading about people, and I wanted to give people a feel for what real paleontology was like, not the old cowboy man going out into the desert image, but modern paleontology. But also to give a sense of how paleontology has changed and how we now study dinosaurs and how we're in this golden age of dinosaur research right now, where somebody's finding a new species once a week on average, where people are using CAT scanners to see into dinosaur brains, where people are using computer animation software, just like the Disney animators used to study how dinosaurs moved, how they walked, how they flew, how big they were. How the field has really changed. It's become technological in some ways, but in other ways, it still is a game, a detective game of going out and finding fossils in the rocks. And we're finding more of them than ever before. And that's because more people are looking than ever before. More people all over the world. It really is a diversity thing. It used to be that very few people in China were looking for dinosaur bones, just a few professors maybe. It used to be that very few people in Argentina and Brazil were looking for dinosaurs. Now you have these great communities of students, of young people, in not only those countries, but in many countries all over the world. And this is why we have so many new dinosaurs. And the trend continues, by the way. We're not running out of dinosaurs, so they're not going anywhere. There's still a lot more to be found. And so for the youngsters out there, don't worry. There's still a lot of dinosaurs out there in the rocks, hiding in the rocks all over the world for you to go out and find. So that's more or less my story. And now, much more interesting, I think, than me telling you the story of coming from Ottawa and studying dinosaurs and so on is your questions. That's what I really want to have an opportunity to hear from you and to answer any questions you have about dinosaurs. So thanks for hearing me out and sticking through the boring bit. And now let's do the fun bit.
All right. Well, thank you very much, Dr. Brusatte. So for the Q&A, if you want to, you're welcome to type questions in the chat. Danielle will be monitoring the chat. Otherwise, if you, on the toolbar on the bottom, if you open up the participants list, there's a button that says raise hand, and if you do that, I'll keep an eye on that.
There's a question in the chat from Hunter and Emma. Why did the birds survive and the dinosaurs die?
That's a great question, and I wish I had an easy answer for you. And I've thought about this one a lot, and a lot of my colleagues, a lot of other scientists. So, and one of the reasons why it's such a good question is because we know birds evolved from dinosaurs. Today's birds came from the dinosaurs. We know that because we have so many fossils of dinosaurs with feathers, with wings. We actually have an evolutionary sequence showing how a meat-eating dinosaur of the T-Rex family, how it got smaller over time. It developed feathers. Those feathers became more elaborate. The feathers turned into wings, and these things started to fly. So Velociraptor from Jurassic Park would have had feathers, and it would have even had wings. It was a very bird-like dinosaur. I know they don't show it that way in Jurassic Park, but that's because the fossils of feathered dinosaurs, they were discovered a few years after Jurassic Park was made. So Steven Spielberg never knew that dinosaurs had feathers. But the point is that, Velociraptor is not a bird. It is a dinosaur. It is a meat-eating theropod dinosaur, and it had feathers and it had wings. So it was a very close cousin of birds, and birds would have evolved from dinosaurs like Velociraptor, which begs the question, why did birds survive the extinction when the asteroid came down? And some of these dinosaurs that looked like birds and there's not an easy answer to that, but some of my colleagues over the last few years have looked at this question and they come up with some ideas, and I think these ideas are good ideas. So one of the things is, we have to actually remember that most birds died with the dinosaurs. There were lots of birds that used to be living in the Cretaceous period. There were birds that had teeth. No birds have teeth today. There were birds that had long, bony tails. No birds have tails like that today. Birds have tail feathers, but they don't have long, bony tails like, say, a brontosaurus or something like that. So you had all these birds that were living with the dinosaurs, and almost all of them died. The only ones that survived were the birds that had beaks, that lost all of their teeth, that had beaks, and they were able to eat seeds. And seeds are really important because we see this in the world today. When there's a forest fire, let's say, a fire that destroys an entire forest, all of the leaves and the flowers and the fruits and all of those things that animals eat, those things are gone. They're burned away. There's nothing left to eat. But what survives in the soil, and what can survive in the soil for decades, is seeds. So if you're able to eat seeds, you can often survive a disaster that kills off the rest of the ecosystem. So I think that's one of the main reasons, it might not be the only reason, but one of the main reasons that birds survived when the other dinosaurs died, because these birds were the only dinosaurs that could eat seeds.
Okay, we have a few people that did the raise hand. Let's see, I see James Stewart. Do you have a question?
Yes. Where is the best spot to find ankylosaurus bones?
The best place?
Yeah.
Yeah, so is that your favorite dinosaur?
Yeah.
Yeah, that's cool. I'm glad you said that, because most people, if you ask what their favorite dinosaur is, they'll say T-Rex. And in fact, that's what I would say. So if anybody is planning on asking me my favorite dinosaur, I'll just give it away. It is T-Rex. And I know that's very cliched. Everybody says T-Rex. And I love T-Rex because it was the biggest pure meat eater that's ever lived on land in the entire history of the Earth. I think that's pretty cool. But I've also studied T-Rex. So, I've studied his bones, and I've done a lot of work on T-Rex and other Tyrannosaurs, so it's special to me. But I think Ankylosaurus is one that more people should have as their favorite, because these, and James undoubtedly knows this, or are you James, or what's your name?
My name is Weston.
Weston, good. So what Weston, the dinosaur Weston's talking about is one of these giant plant-eating dinosaurs that looked like a tank. It was built like a tank. It walked on all four legs. It moved really slowly. Its body was covered in armor. It was covered in armor plates. It had bones growing out of its skin. It had spikes on its body. Its eyelids were bone, so it could close its eyes and no predator could get at its eyes or the rest of its body. And its tail ended with a club that was the size of a bowling ball, and it was made of pure bone. So basically this thing had a bowling ball at the end of its tail, which it could swing around. So if a T-Rex tried to eat it, it would just club it with its tail and send it on its way. I think that's a very cool dinosaur. It lived with T-Rex. It lived with T-Rex and Triceratops and duck-billed dinosaurs. And this was about 66 to 67 million years ago. And this was in the western part of North America, which means you can find fossils of Ankylosaurus today in places like Montana and North Dakota and South Dakota, and probably a little bit over the border in Canada too. I'm not sure, but in Saskatchewan in Canada, there's similar rocks. So Weston, if you want to find an Ankylosaurus, those are the places that that you should go.
Thank you.
And from the chat, a question from Joe. Is there any new evidence to the color of dinosaur feathers?
Yes, there is. And that's a cool question too. Because when I was a kid, like a young kid, learning about dinosaurs in school, before I became really obsessed with dinosaurs, what the school books would always say is, we'll never know what color dinosaurs were. All we have are their bones. We don't know. Maybe they were green like a crocodile or a lizard. Maybe they were brown. Maybe they were a bit fancier with their colors. Maybe they had polka dots. Maybe they were pink and purple. We don't know. But about 10 years ago, somebody figured out how to tell the colors of dinosaurs, at least some dinosaurs. And this is a guy who's a friend of mine now. His name's Jakob Winter. And he came from Denmark. And he was a student at the time he figured this out, which you would think this is something that some big professor would figure out. No, this was a student. He was a student then. He's now a professor. But Jakob figured out that if you have very well preserved dinosaur feathers, you can put those feathers under a super high powered microscope. Not the sort of microscope you might have at home if it's in your science kit, or that you might have at school. I mean like a really high powered microscope called a scanning electron microscope. These things are big. They would be about the size of this room I'm in right now in my house. And they can let you see tiny details. And if you do that, in the feather, you can see these little things that look like bubbles. And these things are called melanosomes, and that's just a fancy name. They're the vessels or the cells that hold the pigment, or that did hold the pigment when the dinosaur was alive. The pigment is the stuff that gives a dinosaur, or really any animal or plant, its color. Our hair has pigment in it. And if you were to look at our hair under a really high-powered microscope, you would see these melanosomes, these little bubbles. Now, what's cool about that is different colors are held in bubbles of different shapes and sizes. So some bubbles are round, some bubbles are longer that look more like a hot dog, some bubbles are big, some are smaller, and we know from modern animals that if you measure the size and the shape of those bubbles, you can tell what color that corresponds to. And so maybe about 10 different dinosaurs have been studied so far in this way, and so far what Jakob and other scientists have seen, including, I should say, a student of mine, a Scottish guy named Angus Crowdis, who did his undergrad and master's research with me in my lab. I got samples from some feathered dinosaurs in China for him to study, and he just did a thesis on one of these dinosaurs. So what Angus and Jakob and other scientists have found is that the dinosaurs that have been studied so far had all different types of colors. They were not just all green or not just all white, But some were white, some had brown feathers, some had black feathers, some had ginger feathers. They were red-headed dinosaurs. Some dinosaurs had shiny feathers, what we call iridescent feathers, like a crow. If you look at a crow, its feathers have a shine to them. Some dinosaurs are like that. Some dinosaurs had camouflage patterns to their feathers. Some had rings of different colors on their tails, like a raccoon. And this is only like the 10 dinosaurs that have been studied so far. So imagine if we were able to study all 1,500 or 2,000 dinosaur species we know of. I'm pretty sure we would see that they had a whole array of fantastic colors similar to birds today. Because remember, birds are dinosaurs. So when you look at the colors of a parrot or a peacock or a cardinal or an oriole or a blue jay or whatever it might be, those are dinosaurs. Those are colors in the feathers. And the dinosaurs that lived way back in time, like the T-Rexes and the Brontosauruses, they probably had a lot of a great diversity of colors like that too.
All right, so I see another hand raise next to Dr. M. Garcia Martinez.
Hello. Can you hear me?
Yes.
Yes.
Hello. I'm not
Hi.
Dr. M. Garcia Martinez. My name is
It's good
Krishna.
to see you. It's good to put a face there. So yeah, thanks for joining. I hope you got my message earlier today.
Yes, I did. It's great to talk to you in person.
Yeah, you too.
Thanks for the great letter. That sounds great. So,
Yeah, so what are you
yeah. So you know your Romanian friend
Mhm.
Matias recently unfortunately died. He discovered Balaur.
Yes, he did. He did. He was with his two sons when he discovered it, by the way. His two boys, they were quite young then. They were on a trip together, and they were going out camping, and they were going out looking for fossils. This was back in 2009, and they were walking by a river, and he saw the bones sticking out of the river. The rock is all red. It's like the color of a brick, and the bones were white. A beautiful color. They were sticking right out. So he collected the fossils with his little boys, which is a great story, but sad to think about how his boys are feeling right now.
Yeah, say Dr. Brusatte, is it true, in your book that Matias, your friend Matias, actually crossed the river to get to a bones with a broken foot?
It is true. It is true. So my good pal Matias, who I mentioned, and Chris has mentioned now, who passed away yesterday. He was an incredible character, and I talk about him in the book. He's one of the stars of the Cretaceous chapter. And I couldn't really do him justice. I talked about him for a few paragraphs. There's a photo of him in the book, but mere words could not do a guy like this justice. And I don't just say that because we're all mourning him now. I mean, he really was probably the most unique human being I've ever known. He was just an incredible character. He was the best fossil hunter I've ever known, by the way. I mean, he had like a sixth sense or a third eye or something. He would see fossils where other people couldn't. But he just was a very just interesting person. I think we all know these people that we meet in life who are just interesting. So Matias, he's not an academic. He's not a professor. He was a geologist. He had his own little company where he would do consulting work. He lived in a town called Cluj, which is a town in Transylvania in Romania. And so when they were building when there was a new road being built, when there was a new building foundation being laid, there are laws that you have to do a survey of the rocks to make sure the rocks are, safe enough to build a building into. So he would do that kind of work. When he was younger, he did a lot of work for oil companies, and he went all over the world, and he spent a lot of time in Africa, basically just with his backpack, just traveling around, seeing where there might be oil. I mean, incredible. I've often wondered if he would maybe spend some time as a spy even. He would never say it, but he's that kind of character. He's always somewhere around the world. He was a cave explorer. He spent a lot of time, and his wife as well, just going into caves. Big caves, deep caves. He was a sailor. He would take his boat out on the Danube River out into the Delta. And he raised his kids, his real outdoor kids. He spoke, I don't know how many languages, I mean, at least 4 languages really fluently. And he was a great artist. His father was an artist, and he was an incredible artist. Anyway, I could go on and on about it. But one of the things about Matyas was he was incredibly intense in a good way. Sometimes in a a bit of a difficult way. You know, if you did something stupid, and there have been times when I've been with him where I've done something stupid, you know, I've you know, broken a fossil, or I've, you know, I don't know, whatever the case may be. You know, he lets you know. That's one of the great things about him. You know, he was very direct in that way. But he was also the most loyal person, the most loyal friend, and he was very protective of people that he loved. But part of his intensity was, although he was he was the kind of guy you would sit, you know, and for the younger crowd, you don't, maybe it's time to say it, but, you know, you'd have a few beers with him, you'd spend an evening with him, you'd have good food, you'd cook out under the campfire, he'd tell stories of his time in Africa. Although he was that very warm character in that way, when it came to fossils, he was a bloodhound. You know, he was vicious, he was fierce, he wanted to find every fossil. And the story I tell in the book is absolutely true. I think I even have a picture of it, a photograph. At the place where he found Belor when he was with his boys in 2009. We were back at that place in 2013, 2014, and he saw a fossil sticking out of those red rocks across the river. And he wanted to go get it. And none of us could see it. He was seeing this fossil from across the river. And we were like, what is this? Where is this? You know, but he had that third eye, that sixth sense. And so he said, you know, I'm just going to go get it myself. We said, no, you can't, because his foot was broken. He had broken his foot the day before. There was an accident in the field. And actually one of the other guys fell on his foot, and it was just a freak accident, and it broke one of his foot bones. And so it was all wrapped up and not in a proper cast. He hadn't been to a real doctor. He didn't want to go to a real doctor, but it was all wrapped up. And so he said, no, you can't go in the water. You can't go in the water. And he didn't want to hear it. He needed to get that fossil. So he walked across the river. The river was probably about 20 feet wide. You know, it wasn't like the Mississippi River, you know, but it was a river. It was fast moving. There were some currents in there. It was a few feet deep, and he walked across it, got the fossil, took it out, actually put it, kind of balanced it, you know, he had a little box or something, kind of balanced it above his head as he walked across the river back to us. And we just watched this. And then when he got back on the other side, he cracked open a beer and said, that's how you do it. So, you know, that's why he was able to find such amazing fossils. Like Belor, he found some bones of some of these enormous pterodactyls. So there were some pterodactyls, like the ones we found on Skye, you know, they're about the size of birds today. They were living before there were birds, or at least before there were lots of birds. But some pterodactyls were the size of small airplanes. They had wingspans of 10 or even 12 meters, so like 30 feet. And Matyas found a lot of the bones of those pterodactyls in Romania. He found a lot of mammals.
Yeah,
you know, he was finding
like
these huge bones.
Quetzalcoatlus? Like
Yes,
big...
like that. Yes, it's a one called Hatzegopteryx, which is like the closest cousin of Quetzalcoatlus. So Quetzalcoatlus was the giant pterodactyl that lived in North America, and at the same time, this giant one called Hatzegopteryx, which maybe was even bigger, lived in Romania. And so he found a lot of those bones, but at the same time, he also was really good at finding tiny bones, including mammal bones. He found so many fossils of tiny little mammals, things the size of mice, that were living with the dinosaurs, including this one that we described together a few years ago called Litovoy. And that one is, the head is just like this. And we put it in a CAT scanner, and we could see in its brain, and we could tell that it had a tiny brain. And we did the calculations, and we found that it had basically the smallest brain for its body size of any mammal that's ever lived. And this was a real mystery to us. But these animals, all of them, Belor, the dinosaur, the giant pterodactyls, and this mammal with the tiny brain, they all lived on an island back in the Cretaceous period. And we know today that islands a lot of times have very strange animals on them, because something might wash up on an island and it finds itself in a new environment. It's cut off from the other members of its species, and it can evolve on its own, but in a smaller space where a lot of times there's less food and less resources. So a lot of times animals on islands, they get small, some of them, some can get bigger, and they can do things like evolve tiny brains. So a lot of, this is evolution. This is basic stuff about evolution, stuff that we know because of the discoveries of Machas. And more in addition to just, missing my friend and a friend to a lot of us, one of the tragedies is with him being so young was there are bound to be just dozens of dinosaurs and pterodactyls and mammals in the rocks in Transylvania right now that will never be found because he won't have a chance to look for them anymore. He was just that good of a collector. I would walk with him in the same places. Yeah, I would find bones. I know what a dinosaur bone looks like. It's my job, but he would spot things that I would never see. And so it's really sad to think about all the dinosaurs that will go undiscovered now because this great man isn't with us anymore.
Yes. My condolences.
Thank you. And you're very kind. And it was very nice of you to send me that email. That was very sweet. And, a lot of us are just really sad. And so, you're a great kid. You really are. So, keep it up. And as I told you before, you got to come and study here with us in Edinburgh. So, a little bit down the line, you come, maybe you do the master's course, you spend a year with us, because Edinburgh's a long way away, and you live in California, right? That's
yes.
Where you're at? Yeah, so especially a long way from California. And, but for 1 year, maybe you can come and dig up dinosaurs with us.
Yes.
Here.
My actual question, thank you very much, is it involves Microraptor. Recent evidence says that Microraptor molted like modern birds do, and that this is solid evidence that it had real actual flying, fly, not gliding. Do you agree with this?
I do. So this is great. I love it that you know about this, because this study was published, I don't think it was last week, maybe the week before. So it's just come out. This is some of the newest research about dinosaurs. And it's really cool. There's a dinosaur called Microraptor. You can tell from its name that it's a velociraptor type dinosaur. It's one of the small little predators, really feisty, nasty little things, but smaller than velociraptor. You could hold a Microraptor in your arms. You wouldn't want to because it had these big sickle claws on its feet. It could rip you apart. But Microraptor, it had feathers and it had wings. And in fact, it had wings on its arms and it had wings on its legs. It's really weird. Birds today don't have this. So there's been a lot of debate about, what is Microraptor? It's not a bird, but is it an ancestor of birds? Did modern birds evolve from these four-winged animals? Could Microraptor itself fly or not? Was it not yet able to fly? People have gone back and forth. People have even built models, physical models of Microraptor, and put them into wind tunnels, the way that like engineers will study if a plane wing can fly and that kind of thing. But still, it's not conclusive. But this new study found there's a new Microraptor fossil, and it died and was turned into a fossil right in the middle of molting. And so molting is when a bird, or a dinosaur in this case, changes its feathers. When a bird is born, it isn't born with all the feathers it's going to have for its whole life. It grows, it gets bigger, and the feathers wear down, and so it changes its feathers, the same way like a snake will lose its skin. And so there's different ways that birds today molt their feathers, but birds that fly and birds that have to fly during the time when they are molting, they don't molt all their feathers at once, because if they did, they wouldn't have an entire wing and they couldn't fly during that time. And maybe there'd be 1 day, 1 week, whatever, where they couldn't fly and they had to stay in the trees or on the ground. And that's really dangerous. That's a really dangerous thing, because you could be eaten by predators or other things could happen. So birds that need to fly and fly well, they always molt their feathers kind of in this sequence. They don't molt them at once. One they lose, but they keep the next one. Then they lose the next one, they keep the next one, that kind of thing. This Microraptor was found preserved as a fossil in the middle of its molt and it showed that sequence. So that means that it changed its feathers the same way that modern birds that fly and fly well and need to fly all the time, the same way they change their feathers. So that is, to me, really good evidence that Microraptor could fly. And so I like the study. I was one of the scientists who was asked to review that paper. When scientists find a new fossil or have a new idea, we'll write it up. We'll write up what's called a research paper and submit that to a publication, to basically a scientific magazine. And before it's published, the editors of that publication will send it out to other scientists to see, okay, is this solid? Does this need more work? Does it need more evidence? And so I was, asked to look at that paper as a reviewer, and I liked it, and I said, this should be published. This is really cool, and it was published. So I was very happy to see that. And these are colleagues of mine in China that did that work, some of the leading researchers on Chinese dinosaurs.
Yeah, thank you very much. And because of its molting, this means that it would have flown a lot, because say feathers would have kept them for life if it doesn't really use them much. But if it kept using them for flying, it would have had to keep growing them back like modern
Yeah,
birds.
you're absolutely right.
Thank you very much, Dr. Brusatte.
Yeah, thank you.
Thanks so much for the invite.
Of course, and keep in touch.
Edinburgh. I'll see you in Scotland.
Yes, we'll see ya.
10 years from now.
Sounds good.
Okay. And then another question in the chat from Kyle. What in paleontology is exciting you the most right now? A new fossil or maybe a new mystery to uncover?
Oh, having to choose one is really tough. I mean, I think what I'm turning more of my attention to as a researcher is to the mammal story. I mean, what's really interesting me right now is what happened after the asteroid hit. It killed off all the dinosaurs except for birds. And then there was essentially this blank world. Not much survived. 75% of things died out. But some mammals survived, just like some birds survived. And from those surviving mammals came us, and cows, and horses, and elephants, and whales, and bats, and squirrels, and so on. How did that happen? Why did some of these mammals survive? What was their world like early on after the asteroid? How did they persist and diversify and spread around the world and change from what were probably, mouse or rat-sized little creatures at that time into whales, blue whales, the biggest things that have ever lived, 100 feet long, 100 tons in weight, bigger than, much heavier, in fact, than a Boeing 737 when it takes off. Incredible. How does evolution make something like that? Or monkeys, primates with big brains, or bats with wings. So that, from an evolutionary sense, is what I'm really interested in. And I would just say more broadly, though, what's great about paleontology is that it's a discovery science. And fossils are the currency of the science. And, the more we look, the more we find. You can never predict what you're going to find. That's a great thing about it. I mean, nobody would ever have predicted that there was a pterodactyl with a 30-foot wingspan that was the size of a small plane. Nobody would have predicted it until it was found. And there's so many other examples. I mean, a T-Rex, who would have ever thought there was something, the size of a school bus that weighed 7 tons and could crush the bones of its prey? I mean, who could predict that? So we never know what we're going to find. We're still finding new things. Anybody can find a fossil. That's an amazing part about this field. That's not true of most sciences. Most sciences, you have to study and train for years, even decades, to get to the point where you have enough experience and expertise and ability to run lab experiments, to do the theoretical work of particle physicists, that kind of stuff. But not paleontology. Anybody can find a fossil. When I was in high school and I took my parents' car out, into the forest and along the streams and started to collect those snails and corals and other things, I was just a kid doing that. I was just picking this stuff up. Many of the best fossil discoveries are not made by the professors they're made oftentimes by the students on the professors' teams, as we've seen already with my team on Sky. I don't find the best fossils, and the pterodactyl that Amelia found is just one of many examples of things that students found. Some of the best footprint sites, two of the new footprint sites. One was found by one of my PhD students who's graduated, a guy that came over from Italy to study, and another was found by a Brazilian student who came for a 4-month placement with us. So a lot of the finds are made by students that don't have a lot of experience, at least yet. But also, a lot of fossils are found not by anybody even in the realm of science or research or universities or museums. A lot of fossils are found by farmers, by construction workers, by hikers, sometimes even by kids who are out hiking with their parents. And I love that about paleontology, because it is like the most unelitist, field of science out there. Anybody can go out. And that's what I tell people when kids especially email me, and oftentimes, and not only kids, by the way, people maybe that are looking to change careers, or people that are maybe are a bit older that have read my book and are inspired and they want to make a contribution or start doing some paleontology. One of the first things I always say is, anybody can find a fossil. So no matter where you live, there's bound to be something within driving distance or bus distance or whatever, where you can go out and find your own fossils. Maybe they're not dinosaurs, maybe they're not pterodactyls, maybe they're clams or snails or whatever. But do some research, do some reading, figure out what the geology is like, figure out how old the rocks are, and get out, get a rock hammer, get some chisels, get some sample bags. Make sure you know the laws wherever you are, of course. If it's on private land, make sure you know who the landowners are. You don't want somebody chasing you with a gun. You don't want the police coming out after you. That happened once to me when I was in high school. But all that aside, anybody can go find a fossil. So that's the best way to get into the field.
All right, so I see a hand raised next to Ethan and Stacy. Did you have a question?
There you go.
Yes, I do.
Go ahead.
Where is the best place to find fossils?
In the U.S., right?
Mm-hmm.
The best place, did you say?
In the U.S. Mm-hmm.
Yeah. Well, it really depends on what kind of fossils you want to find. So if you want to find dinosaurs that were there when the asteroid hit, the very last surviving dinosaurs, T-Rex, Triceratops, those dinosaurs, you want to go to Montana, you want to go to the Dakotas, because that's where the rocks are of that age with the right fossils. If you want to find fossils of the biggest dinosaurs with the long necks, things like Brontosaurus and Diplodocus, Brachiosaurus, you want to go to places like Colorado or Utah, because that's where rocks from the Jurassic period are, and that's where those fossils are found. If you want to find the oldest dinosaurs, or at least the oldest ones in North America, you want to go to places where there are Triassic age rocks with fossils, and those are places like New Mexico and Arizona. But maybe you're not interested in dinosaurs at all. Maybe you want to know what life was like 290 million years ago when the world was much hotter and the supercontinent of Pangaea was coming together and there were big swamps across all of the tropical and subtropical areas. If you want to know what the world was like then, during the time that a lot of the coal that we mine today was formed, a product of those trees in the swamps being buried, best place is northern Illinois, a place called Mazon Creek. This is just a little bit south of Chicago. This is in the Braidwood, Wilmington, Coal City, Mazon, kind of Morris area. My hometown of Ottawa is right on the western edge of Mazon Creek fossils. But that's the best place, not only in the US, but in the entire world, to find fossils of that time interval, of the trees that were making those swamps and turning into coal, of the little bugs that were living in the trees, of the little reptiles that were scurrying around, of the jellyfish and the fish and other things that were swimming offshore. And I could go on and on. If you want to find ice age mammals, there's other places. If you want to find crocodiles, there's other places. But the point really is, there's so many places to find fossils and so many different places to go depending on what fossils you're interested in.
Dinosaurs, for sure. Okay, Ethan. Is that it?
Mm-hmm.
Okay. He has a whole bunch of fossils next to him. So,
Oh, that's great.
so he's
It's like an
playing.
oven tray full of fossils. Incredible.
Okay, there you go. Is that it?
Mm-hmm.
Okay.
Okay, and then the chat, a question from Samantha. What bones did you discover?
Oh, well, this is where things get a little bit embarrassing, to be honest, because I've described a lot of dinosaurs. I've named, I don't have a list. I'd have to go through like all my research papers and count them up, but I don't know, probably like 15 or maybe even 20 by now, new species of dinosaurs. And so, oftentimes you might see people say, oh, like Steve has discovered a dozen dinosaurs or whatever. That's kind of true, kind of not. When I name a new dinosaur, like, I'm the person or one of the people of a team who realize that it's new and describe it and give it a name. And that doesn't mean that I've actually found it. And most of the dinosaurs I've worked on, basically all of them actually, other people have found. And I've described new raptor dinosaurs from China covered in feathers. They were found by farmers working their fields and were taken to museums. I've described a tyrannosaur from China. Thing we gave the nickname Pinocchio Rex because it was basically a tyrannosaur, a T-Rex with a really long nose. And that was found by a construction worker, by a guy who was using a backhoe to dig the foundation for a building. So as far as bones that I've discovered, I've never personally, I don't think, discovered something new. Well, that's not true. I've discovered at least one new mammal species in New Mexico, but we haven't named it yet. It is tiny. This is a tiny, it's like a little dandruff flake. I don't know how I saw it. I must have been channeling Machas's energy. But I found bones of different types of dinosaurs, of Triceratops, of duck-billed dinosaurs in Romania, little dwarf dinosaurs. I found, part of a skeleton in Romania of one of these small dwarf dinosaurs, and I was walking in front of Machas because he would have seen it, but I just got there first. I've discovered lots of mammal jaws and teeth and that kind of stuff in New Mexico. Lots of different things, but I don't think I've ever myself actually found anything that's that spectacular. But I'm very lucky to have students that do, and colleagues, people like Machas and others that have found a lot of great stuff that I then help them. I work with them and together, because almost all science is collaborative. We describe the dinosaurs together.
Okay, I see a hand raised. Jason Chappis, did you have a question?
Hi, can you guys hear me?
Yeah.
Yep.
Hi, Steve.
Hey there.
Oh man, it's an honor talking to you. I'm a huge fan.
Oh, well, sorry, that's kind of sad, but okay.
Yeah, I think I'm the oldest person here to raise their hand. So, I just have two questions, and I'll try to make them really brief so that we can get to everyone else. But so just a quick background about this. I just got a degree in biology from my local university. I'm 26.
All right, congrats. That's great.
Thanks. And I love biology also, but I kind of want to go in and apply that to paleontology. It's been my passion since I was a kid, and I've just always wanted to be a paleontologist. And I've just been applying to different places to try and get some experience. And right now I'm taking a couple GIS courses, mapping courses, because I think that would be useful. Yeah. Yep. And I just landed an internship at the Museum of Northern Arizona, but it got canceled because of the lockdown, and so I'll have to wait. But do you think, like, based on that, I'm kind of on the right track to getting into paleo, and what extra skills do you think I could pick up?
Yeah, no, I think you're doing everything right there. I mean, the first step, and my advice is always different. And always, people ask me about this, I'll either ask them or kind of in a roundabout way say, is this something you want to do as a career, or is this something that you want to do, even if really intensively, as more of a hobby? And for you, this seems more like a career thing. And so, what you need for a career really is a degree in biology or geology. Either one is fine. Now, to do the whole professor route and all that, you have to do the master's and PhD. To work in museums, to some curatorial jobs, some fossil preparation and conservation jobs might not require a PhD, master's only, sometimes even bachelor's only. But regardless, the first step is that solid undergrad geology or biology degree, or maybe another science. But those are the two real core sciences. And then from there, it's getting experience. It's like any other profession or career. It's trying to find a way to get an internship, to get kind of an entry-level job, to do some volunteering, both to get experience, because very few undergrad degrees are specific to paleontology. It really is a niche field in a lot of ways. So, while you probably now know a lot more about biology than I do, because it's fresh in your mind. It's been a while
I wouldn't
since
know about that.
studied. But I'm sure you didn't study the details of fossil collecting and conservation and all that stuff. So that's what you get by volunteering, by doing an internship, which is exactly what you're doing. And the place to do that is a museum or a university. Museum in Northern Arizona is a great place. Huge legacy in the field of paleontology. Huge legacy and a great collection. Amazing part of the country for fossils too. Also, they're a repository, I believe, for the Navajo Nation. There's great, some of the most incredible fossils from Navajo land. So that's good. The GIS stuff you're doing, I think that is that shows huge signs of ambition and that's new skill. It's super handy skill. It's important for paleontology. It's also a transferable skill for working in other areas of science, especially in geology. So it's something you can use either to kind of keep yourself going if there aren't a lot of paleontology jobs or opportunities, or maybe even down the line, you figure out that's what you're really, really, really good at. So that's good. So I think you're doing everything right. I think the next thing for you is, if you want to do this professionally, it's a master's program, and it's finding a good program. In the US, masters are usually 2 years long. You usually do some courses. You usually then do a research project. Most master's programs, and basically all PhD programs, you should not be paying for these. You should be getting a stipend to do them. Now, that means you'll be teaching and you'll be doing some research assistantship to basically earn that stipend. And it's, you're not going to be rich from that stipend. But, you shouldn't be paying for that stuff yourself. So, look at what master's programs are out there locally. I don't know if NAU has one. They definitely have a very good undergraduate program. I've known people who've done that program. But, it might be University of Arizona, it might be University of Mexico, it might be, USC or UCLA or something like that in Southern California. Or you might want to go further afield, but just do a bit of research and see what programs are out there. And that would be the next step for you professionally.
Sounds good. I'm in Canada right now, so.
Okay, well, and a lot of masters
all the way away.
So it sounds like you're casting a wide net there, and that's the advice I would give everybody. I mean, one of the realities of the field, me kind of growing up in Northern Illinois and now living in Scotland, is you don't necessarily have to move and live abroad and all that. You don't have to, but if you're willing to be flexible, it just makes life a lot easier, because there are not a huge number of jobs. So if you're able to cast that wide net and willing to live somewhere else, even if it's just for a bit of time, that's just going to really increase your options, and it'll help you, meet more people, learn new things, get into other networks and research groups. So
yeah, unfortunately, I kind of live in a part of the world where there aren't any fossil-bearing rocks, unfortunately. But,
yeah, the Canadian Shield is one example of that.
Yeah.
That's so. Yeah. You might have to drive a little bit further afield. Take some vacation time if you can or whatever. That's some of the best ways. And yeah.
And I'll just try and make one more real quick question.
Yeah.
So how do you differentiate between a fossil like a dinosaur bone, especially a really small one,
Mm-hmm.
and the rocks that is entombing it?
Yeah, no, that's a good question. I mean, it's not always obvious. Like, we spend a lot of time when we're out in the field debating, like, is this thing a bone? Is it wood? Is it a rock? You know, and you would think, oh, these guys with all these PhDs and all these professors and stuff, like, you'd know that. Well, no, because every fossil looks different, and every fossil is rock. I mean, a dinosaur bone is something that used to be a bone that's turned into rock, that's now inside of other rock. So sometimes it is obvious, and I mean, normally what we look at is color, texture, and shape. So a lot of times the fossils will have a slightly different color than the rock, but not always. They should have a texture, especially if you see a broken bone surface. You can see that honeycomb texture. And shape. I mean, you know, if you find a skull or a jawbone or a femur, I mean, that thing has biological shape to it. It has curved edges and straight edges. It has symmetry, you know, the type of stuff you wouldn't get from just a random rock kind of globbing together. So those are the things we look for, but sometimes it's not obvious, and you need experience, you need a good eye, and even with that, we still spend a lot of time arguing back and forth when we're actually out there looking for fossils.
Yeah. Well, thank you for answering my questions. It's an honor meeting you.
Yeah, my pleasure.
And,
well, good luck with everything, and keep in touch. And I hope the NAU internship can start up again, and you can spend some time out there in Flagstaff and around, and just in a great part of the world. And so, but
Yeah.
do keep in touch, and I look forward to meeting you at one of our research meetings, Society of Vertebrate Paleontology, or another conference one day soon.
Yeah, absolutely. I'll head out saying my favorite dinosaur is Therizinosaurus.
Okay, that's a good one too, with the big claws.
All right. Have a good one.
Yep, take care, Jason.
Take care.
Okay, let's see. We're getting close to 2:30,
Yeah, so
hopefully
I can do some rapid fire now, if that's
Okay.
okay.
From the chat, how do you feel about the commercial fossil hunters who do it primarily to sell their finds? There was a TV series about these people here in the US on Smithsonian Channel. It seems you touched on this in your book, but I would be interested in hearing more. That's from Ira and Jackie.
Yeah. The show was on Discovery. I don't think Smithsonian would do a show like that now. They're a little bit higher standards, let's say. Conflicted, I'll say. I mean, the thing, it's a big can of worms to get into. I mean, I think any important fossil should be in a museum, so it can be kept safe, so it can be put on display for people to be inspired, so the public to be inspired, and so it can be kept safe for researchers to study it. That doesn't mean every single clam or every single tooth or whatever should be in a museum. So we need to make sure people can collect fossils, and it doesn't become this gate kept field where only a few professors can do it. We got to make sure that laws are always followed. This is important. In the US, the landowners can do what they want with stuff on their land. That's the law. That's how we operate. In China, in Brazil, and so on, that's not the case. But you still see Chinese and Brazilian fossils for sale a lot of times. That's illegal, and that is an absolute no-no in every way. When it comes to dinosaurs from the US being found on private land and being sold, I want those fossils in museums. That's the end game of that. I know people that dig up dinosaurs for a living. Some of them are excellent. I mean, they're much better fossil finders than me. And they're diligent, and they're intelligent, and they've studied, and they have a lot of experience. Now, there are some on the other end of the spectrum that are, fly-by-night cowboy operators. That I don't like. But by and large, important fossils, I want them in a museum. And I want the laws to be followed.
Okay, thank you. Chat, another one from Matthew. How important is it as a scientist to write popular science books like Rise and Fall of the Dinosaurs? As an academic, how did you get or find opportunities to work on so many books for the general public?
Yeah, Matthew, if you're still there, it's good to see you here. Hopefully you're doing okay. And hopefully you're still planning on joining us for the master's course. So, I mean, I think that it's important. And, I think for somebody like you, since I know you and I've known you for a while, and I know your passion and your enthusiasm, I know that you're, very articulate person, and I mean you've been on TV, like you've been on a major British TV show, talking about dinosaurs. Like that's really cool, and that's great. You got that opportunity. For me, I think it's all important, and I think when it comes to opportunities, the way that the one show worked out for you is how stuff has kind of worked out for me. Some stuff has fallen into my lap, some stuff has just kind of come my way. I've taken opportunities where they've come. When it comes to writing books, Mike Benton got me the opportunity to write my first dinosaur book. Mike writes a lot of kids' books. There was a project he didn't have time to do. I was his master's student. He passed my name on to the publishers. It was that connection that really got me started. And so, I was fortunate there. That was a real moment of just good luck. At the same time, it was an opportunity, and I took the opportunity, and things follow from there. So if the opportunities arise, take them. And, because I do think it's important, and not every scientist maybe is going to be able to speak to the public. You do have to be enthusiastic and passionate and all that, but you are, Matthew, and, so for those people like us, I think it's a good thing for us to do. So I can follow. So around Lauren's question, I'm just going to start going through these.
Okay, thank you.
So so Brontosaurus, this has been a long debate about how we name dinosaurs. And when it comes down to it, a long time ago, well over a century ago, somebody found the bones of a big long-necked dinosaur, and they called it Apatosaurus. And then somebody very shortly after found another big long-necked dinosaur and called it Brontosaurus. A little bit later, another scientist came along and said, actually, those two dinosaurs are the same. We can't tell them apart. So they're a single species, and the name that's given first is the one that has priority. That's the rule. So Brontosaurus was no more, because it was only Apatosaurus. But now, a few years ago, another team of scientists, with the benefit of modern understanding of the diversity of dinosaurs, found that actually Apatosaurus and Brontosaurus do have differences. So Brontosaurus is back as a name, and I love it because it's a dinosaur name we all know, and I love that I can use it. From Erica, dinosaurs ectothermic or endothermic? This is the warm or cold-blooded debate. This has been a debate for a while. There's no slam dunk answer here. We know that dinosaurs did become warm-blooded at some point in their evolution because birds are warm-blooded. We also know that a lot of dinosaurs, even things like T-Rexes, they grew fast. They were energetic, they were dynamic, they could move fast. And so that's much more in line with a warm-blooded animal than with a cold-blooded animal like a crocodile or a lizard that's really sluggish and has to go out in the sun and bask and warm up. With that said, though, I mean, we can't stick a thermometer in these dinosaurs and see how their body temperature changes over the course of a day to see if they're really properly warm-blooded. So I think that, yes, probably some dinosaurs were warm-blooded, or at least were kind of intermediate, and then at some point later, birds became properly warm-blooded. Michael's question about pterosaurs, yeah, great question. I mean, we have this great sequence of meat-eating dinosaurs developing feathers, developing wings, getting smaller, turning into birds. We don't have that for pterosaurs, and we don't have that for bats either. Bats are the third group of animals with bones that have evolved flying. We do not have good fossils of their ancestors. So we don't know yet. Did they develop wings quickly or gradually? What sort of intermediate stages did they go through? People will probably find the right fossils one day. It's just really hard because these are small animals, animals that were probably living in trees, animals with very delicate bones, and it's hard to turn those things into fossils. So we have to be lucky, and the reason we have so many fossils of these dinosaurs with feathers and wings is because they were killed by volcanoes, Pompeii style, in China, entombing, probably hundreds of thousands of these things. So bad luck for the dinosaurs, good luck for us. Okay, Samantha, what are bones made of? Bones are made of a mineral, a hard mineral with phosphate in it. That's the simple answer, and calcium as well, of course. That's why we always worry about calcium with osteoporosis and so on. So drink your milk and make sure you get that calcium. Yeah, the question about studying college and so on, I think I answered that with Jason's. Thank you, Hannah, and Noah and Micah. That's great. Oh, and let's see. Same thing with Samantha's question. What steps you take? Good undergrad degree in geology or biology. Don't worry too much where it is. Don't worry too much about working under a famous professor. I did it. I was lucky there. But what's even more important is just getting a good background in either geology or biology, and then doing a master's course to specialize more. And then if you're really into it and you really want to do it, then you jump up to PhD. How do we know it's dinosaur bone? I think I kind of answered that with the color, the texture, the shape and symmetry. Yeah, the show called Dino Hunters. Yeah, I do not endorse that show. Let me just say that. The people that are on that show, by the way, are not the sort of scrupulous, highly trained private collectors that I know and that I respect. That might sound harsh, but if those of you that see the show, the people on that show are basically people that call themselves things like the dinosaur cowboy, the type of people that hack bones out of the ground and try to sell them as quickly as they can for as much as they can. If people are going to sell dinosaurs and following the laws and so on, do it right, do it carefully. Yep, and thanks, to everybody who's saying hi here. Okay, I think that's the end of it. So, yeah, good. Well, I think that's good.
Okay.
To get down, we're gonna have dinner now with my wife and her sister visiting, so they probably want me downstairs. So, just thanks everybody for joining us. Thanks for all the great questions. Great to put some faces to some names here of people exchanging emails and so on, and just those of you that want to keep in touch, I'm easy to find over email, and hopefully I can meet some of you guys in person one day when the world gets a bit better and I'm back in Northern Illinois.
Thank you very much.
Thank you.
Thank you, Dr. Brusatte. We really appreciate your time and being able to do this with us.
Yeah, my pleasure, and I'd love to do it again down the line. I'm going to do a mammal book next for adults,
Okay.
but I have a younger reader's version of The Rise and Fall of the Dinosaurs coming
Hey,
out.
Dr. Brusatte? Dr.
Mhm.
Brusatte?
Yeah?
Your new, I'm very excited about your new mammal book. I heard about it.
Me too. I'm excited about it, but I'm also frustrated with it because I'm writing it now, and it's
I
like
know.
it's taking a lot of my time, and I don't have a lot of time with the
Yeah,
pandemic.
it sounds great. I'm going to really enjoy reading it.
Yeah.
I think you should have a chapter dedicated to the South American megafauna. Macromedia, Smilodon fatalis, Forestrakis and platus. It's not
Yep.
a mammal.
I like that
Like
idea.
Loxodon.
I like that idea. I'm definitely going to have a section. It might not be an entire chapter because I probably only have 10 chapters, so I'll probably need to talk about the northern ice age, mammals, mammoths, and saber-tooths and stuff. But there will be a South American section. I promise you that. All right, I better get down to the family. So thank you, everybody. This was a lot of fun, and stay safe, stay well, wear your masks, and hopefully we can all meet in person one day soon. All right, bye, everybody.
Thank you so much, and thank you everybody for participating. We're glad that you could join us.
Thank you.
Take care now, okay?
Thank you, Sean. Thank you, Danielle.
You're welcome.
Welcome. Bye.